Hello, welcome to a special Monday edition of the Coding Train. I am Dan, your host and coder person. It's Monday, it's not my usual time. The reason I'm here today is not because I want to be more like fun function, although, I don't know, how many funs are there in fun function? I think I got it right, 3, right? But rather that I have just a conflict for later this week. And typically I like to live stream on a Thursday or a Friday, sometimes in the morning, sometimes in the afternoon. You're all over the world. Your time is a completely different time. But this week I won't be here later this week, so I am here today to make sure it's my goal at least this summer to have a live stream every week, although I can say for certain when that's not going to happen in July and August when I'll be away. But anyway, here I am. And I've got a bunch of things to do. I'm looking at the chat, and so far no one's complained that my volume is too low or it's too high, so everything seems to be rolling along. Okay, so what's going to happen today? I got to think about this for a second. Okay, so first let me say, perhaps this is your first time watching. If it is, welcome. Thank you for tuning in. I hear that there's like another live stream, maybe the E3 live stream is going on, right? Maybe simultaneously. You probably should go watch that. This will be archived. You can watch it at 2x speed or fast forward through it later. Okay, so if this is your first time watching, what I do is I typically live stream. Today will be the same for about 2 hours. I definitely have to leave 2 hours from now for an appointment. So I'll be here for about 2 hours. I make a lot of mistakes. I try to code a bunch of things, explain a bunch of things. And then after the live stream is finished, it is archived. And also most of the time, various portions of live streams are then edited separately into tutorial videos, which are uploaded later. If you would, which I will mention, by the way, while I'm here, since I'm here, if I go to youtube.com/Schiffman, and okay, so what you will see here is that the most recent videos are my Perceptron coding challenge, which I'm going to do a follow-up on today, and the Frogger live stream, which I'm also going to do a follow-up on today. So that's what's happening today. But I will say, if you go here into coding challenges, what you might notice if you scroll all the way down to the bottom, load more, all the way, look at this. Coding Challenge 73.1.2 and Part 3, Frogger Part 1, 2, and 3 are actually available. So often, I'm just saying this because people always ask, and also for you, the live viewers, to give you a little extra tidbit here. When the edited versions of the videos are ready and available, they're often uploaded and part of the playlists, but are unlisted on YouTube and are not made public. This is because I tend to make one public per day. Most of the viewers are not the live viewers, but are the ones who are just kind of clicking on links as they get alerts. So I like to kind of roll out the videos more slowly over time. Maybe that's a bad idea. I don't know. Some YouTube certified consultant could maybe tell me the best way to approach this, but that's kind of my approach for right now. Okay. Welcome Vic, who says, wow, the first time I'm here. I am glad that you are here live. I don't know if this experience is more enjoyable or less enjoyable live, but I'm pleased nonetheless that you're here. As you saw, I do try to keep a corner of my eye on the YouTube chat. It's very hard for me to follow it. Because I got to think about a lot of different things. It's also on a screen that's like all the way over here. So I have to like look and kind of look over here and then come back and look here. So I will try to take a peek at it. I do keep a closer eye on a Slack channel, which if you would like to support the work that I'm doing, patreon.com/codingtrain. Patreon is a crowdfunding service for content creators. And if you would like to join that, you will get an invitation to our Slack channel, which I also keep an eye on. And the most recent messages in the Slack channel seem to be about people like finishing up their lunch real quick or skipping eating just to watch the live stream. I really don't recommend that. First of all, as we all know, on the Coding Train, I need a sound effect for this. It is very important, not one that's going to make me feel like I just have to go pee, but it's very important to stay hydrated. Is everybody watching staying hydrated? I don't want anyone feeling woozy, especially myself. Stay hydrated. I have my purple canteen of water here. I also recommend that you eat lunch. Go eat your lunch. You can watch while you eat your lunch. All right, Gregory in the YouTube says, I need to go to a dancing lesson. Oh my goodness. Wait a second. Isn't this channel really just, I mean, it's like if there's no lessons involved. But I would like this to be a dancing channel. Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it. Okay, I think that's enough for right now. I know whenever I start to pull a muscle in my neck, we know it's a problem. I've actually been watching The World of Dance, which is a great show. I don't know if it's a great show, but I've been enjoying it. Lots of great dancers on there. Okay, I am clearly not going to be on The World of Dance anytime soon, but you know, I have this YouTube channel. I guess that's something. I don't know why I'm doing this anymore, but I'm here. Okay, wait. So I was talking about Patreon, and then I looked at the chat and got distracted. Okay, so Patreon, I said, I think I always plug my, the two other things I like to plug, I should do this in the opposite order, are codingtrain.storeenvy.com for some merchandise. And also processingfoundation.org. Processing Foundation is a non-for-profit 501c3 corporation here in the United States. Our mission is to do a lot of different things around code and education. Processing Foundation maintains processing, P5JS, processing.py, Python mode, and also does a lot of community and education and diversity initiatives. You can read all about processing on the website, and I encourage you to become a Processing Foundation member, and I encourage you to do that before you do my Patreon. Okay, so I don't. Simon in the chat writes, "Come on." I don't know if that means skip with all the dancing and just get to the coding. But you know, some of the people, they tune in. No, does anybody tune in for the dancing? I don't think so. Every once in a while, somebody says that they tune in for the dancing. Okay, does processing have a separate library if you say want to use the libraries in Eclipse? I'm so glad that this question was asked by Jimmy in the chat. Oh, and also before I get to, let me forget about this Eclipse. Tech Nerd, people want the fidget spinner video. Tech Nerd asks about Discord. I'm kind of old, I guess, relatively. You know, I'm young in many ways, young at heart, and youthful. But I'm kind of like not so up on the current stuff. You know, I do have, maybe I'm up on fidget spinners and Pokemon. Does that count? No. Okay. Anyway, but what was I talking about? Discord. There is a Coding Train Discord. I guess it's unofficial. I don't know anything's official or unofficial. And the reason, there's also a Coding Train Reddit, reddit.com/r/Coding Train, which I was really like, I used it 1 week and then, okay. But down here we can go to Coding Train Discord. If Discord is something that I should consider using as a platform, I love to be able to expand and make ways for people in this community to I'm reading the chat. Oh my gosh, so much. Can't read. See, this is why I can't read the chat. It's very hard to multitask. But you can check this out. So I don't know. The Slack channel has worked well for me for this Patreon community. The YouTube chat works well for the live sessions. Okay, so the Discord, you can just find it here. Someone post this in the chat for those who are interested, and maybe I'll try to check it out sometime. Okay. I noticed, by the way, that I say okay a lot. So maybe that's the next song. Okay. So I think that is all of my introductory stuff. Am I forgetting anything important? What do you think? Soon the camera will shut off and I'll have to go press that button. So next up. So what do oh, this is something I want to show later. This is by Kay Weekman, who is a contributor to Coding Train community and does a lot of has been making a lot of great machine learning examples. I'm going to show this a little later. I think here are the things that I want to do today in the time that I am looking at my watch. I want to do a follow-up video on the Perceptron, which was a coding challenge, and it was finished. This is the example. running here. This is a simple perceptron that's being trained to recognize points on one side of a line versus the other. So I want to add some features to this and talk a bit more about it, as well as talk about what the limitations of the perceptron are and why a multi-layered perceptron, a neural network, so to speak, of many interconnected perceptrons, expands the possibilities of what you can do with neural network-based machine learning. So that's kind of, I'm not going to build the fully connected network, the multi-layered perceptron today, but I want to leave myself with everything finished so that the next time I come and do a live session, we can really start to build the neural network library. I would also like feedback, I guess not right now, maybe I'll do a straw poll or something. I made this neural network library in JavaScript for some P5.js examples, and I don't know if I should rebuild it from scratch as the tutorial videos or just do a processing version. I have to think about that. Okay. Nose touch. Yeah, this will be the okay song suggested by Alka. Okay, 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 okay. My nervous habit apparently is touching my nose. You can tell that I'm getting like stressed out and figuring out the code stuff. So that's item number one, is to follow up on the Perceptron coding challenge. Item number two is to follow up on the Frogger coding challenge. I have two things that I want to do. Definitely won't be able to do both today. The first thing is I want to do just a refactoring video. So I want to look at, there was so much spaghetti and kind of mess in that example that I made that I want to do a fourth part, which just refactors it. And the major thing will be adding a lane object, the lane object storing a number of cars or logs. And I probably also, we realized that the cars and logs actually can be, there it goes, can be the same object. So I might rename that to obstacle. This was suggested by me. I am so me. And so that's the other thing that I want to do. I think I have time to do both those things. I was thinking, my coding challenges where I do a particular game all in one video tend to actually be viewed more. So I thought I might try an experiment, which is, and I guess I won't do this today, but somebody remind me, which is I did the Frogger challenge in processing, and it's in 3 parts. It'll now be in 4 parts. And I thought I would try to do like sort of a speed version of it. Since I've done it once already, I might have an easier time of coding the whole thing from scratch in one video, and then I would do that in JavaScript. So that is that. Okay, processing fidgets. I know there's the fidget spinner idea is very polarizing because it's kind of like, come on, really, you're going to do a fidget spinner YouTube video et tu coding train? At the same time, hey, you're going to do a fidget spinner video. That sounds interesting. But there is something there in terms of looking at angular motion, some interactivity. There's a really interesting thing that you might not think about, which is that when you click on something and want to drag it around, you've got to know where you clicked relative to where it is. And with something spinning, it all has to do with angles. So there's actually a few interesting kind of graphics and maths tidbits. Okay. All right, so I'm looking at the chat. Oh, Discord bot making thingy, a tutorial on a Discord bot. I said I would do that? Apparently I said I would do that. Oh, I might have. Okay. Okay. I'm very self-conscious. I have a self-consciousness problem. Let us begin. It's been a while since we read from the Coding Train storybook, a million random digits with 100,000 normal deviates. Now you might remember last time where we left off was 442,202. 52,776, 21,319, 74,135, 3,300, 29,702, 10,847, 18,763, 49,177, 85,289, 27,000, 31. Hey, good night, children. Don't let the bed, I was gonna make some sort of the bed bits bite. Don't let the bed bits bite. All right, then something I also like to do, maybe I'll do this at the end. I'll do my Red Burns quote before I leave. Okay. I know there's some people who haven't watched this before. Okay. Now we're really gonna get started. So with this Perceptron Perceptron example, let me think of what I want to do. I want to make it a bit more interesting visually. I think the two things that I can do is, number one is right now this is just, where do I create the training points, right? The training points are dividing points whether on one side of a line or another, and that line is just y equals x. So what I want to do is have a more flexible line. I also want to reorient it so that I think about the screen as having 0, 0 maybe in the bottom left or in the center. So I want to like map all the points, I think would be good. And then I want to visualize where the perceptron thinks the line is and where it actually should be. So I'll do that. And then I also would love to actually visualize the perceptron itself, the weights, the inputs coming in, that sort of thing. So, so that's what I'm going to do. Okay. Why did I say okay a lot? Because now it's all I can ever think about. Oh, Calgon, take me away. I don't know if anyone will get that reference, if that is a reference to get. So this will be, I think this will be coding. I somewhat regret making the Perceptron a coding challenge because it's really more of a it's really part of more of a tutorial series. Although I did like the idea of like, hey, let's make a Perceptron. It's a coding challenge. Maybe these follow-ups should be, this one will be just coding challenge Perceptron follow-up. That's what it'll be. All right. So here we go. Hello, welcome to a follow-up on my previous Perceptron coding challenge. So if you happened to watch the previous one, and if you hadn't, you probably should go back and watch it, link in the description. I created a simple perceptron. A perceptron is a model of a single neuron that receives inputs and then produces an output. And this is a very simple scenario where the output is only trying to guess whether a point is on one side of the line or the other. Is it above this line or below this line? So in this follow-up video, what I would like to do is really just refine this example, nothing really about the mechanics of the perceptron itself, but make this example a bit more sophisticated and allow for some more, hopefully possibly some more creative possibilities. So first thing, I got a bunch of things I'm going to do. I would list them all, but I can't remember what they are. So I'm just going to tell you what the first thing is. The first thing is I would like to, and let me come over here to the whiteboard. The whiteboard is black. Take two. Let me come over here to the whiteboard. So what I did with the first perceptron was just use the raw pixel coordinates of the processing window. I can't remember what size it was, but it was like a 640 by 480 window, and 0, 0 is over here, and this turned out to be the line, and I was looking for points over here. But the idea of using a neural network-based system is typically to get some kind of data input that's not based on pixels. So what I think that I want to do here is just redo this example and consider a Cartesian plane with 0, 0 in the center and y pointing up. So whereas this is 0 and this is 480 down here, 480 would be kind of up here. So I would like to just redo this whole example, and then the line y equal x we should see as appearing like this. The reason why I want to do this is the next thing that I'm going to do is create a perceptron that will learn any division of data points. So it doesn't just have to be a division that's slicing it right down the middle. So first let's make that change. Okay, so how do I make that change? Well, where do I make the points? I think I had this point object, and the point object makes a random point with a random x value and a random y value. What I'm going to do, and I think, I'm going to just make these now random values between -1 and 1. -1 and 1, okay? So the random values are between -1 and 1. In some ways, that's it, done, aha! But now, right before I show them, what I want to do is I'm going to say px for like pixel x, and I'm going to map x, which has a range between -1 and 1, to 0 and width. Map is a built-in function in processing that takes a value with one range and maps it to another. It's very simple math, and I actually have a whole other video, which I will try to link to, that goes over the map function. And y, I can do the same exact thing. So let's look at this. Except for with y, right? What I want is y. When the y value is high, I want it to be low in terms of, when it's high, I want it to be, it's flipped, right? 0, 0, instead of positive pointing down, it points up. So I want to reverse that mapping. And the map function does that for you by saying, hey, when y is -1, it should be at the bottom. And when y is 1, that's a nicer way to say it, it should be at the top, 0. Okay, now what happens if I were just to run this? It kind of looks like a whole lot of nonsense, right? Didn't seem to work. Well, first of all, I forgot a major thing. I did the mapping, but I'm still drawing the ellipse at those values. So I'm going to say px, py. Okay, good. Look at this. There are all the points. And you can see how they're divided, but the line is drawn in the wrong place. So where do I draw that line? I draw that line right here. Okay, so, just time out for a second. I realized I forgot something else I wanted to add. I'm going to edit this out. Or Mathieu's going to edit this out. Which is a comment, and I should have opened it with that, but that's fine. I'll come back to it. There seems to be a lot of nonsense going on in the chat, so I need to not look at that because it's very distracting to me. Okay. Right, because I'm going to change okay, I'm coming back. So I'm just going to change the coordinates. I'm going to hard code new coordinates for the line. We'll deal with that later. But so I'm going to say 0, comma height to width, comma 0. And we should see, there we go. There are all the points. Now, what's going on? Before I had this thing in this program, where I would draw a red or green ellipse whether or not the perceptron had guessed correctly. And that's not working anymore because I am not doing the mapping anymore. So I need to also just take this same exact math, and probably I should package that into a function or make it part. Oh, you know what I should do? I should make, the point object should just have a function that's called get pixel x. It's a little bit of an awkward naming. Get pixel y. Let's just call it, forget about pixel x and pixel y. So I'm just going to calculate these on the fly whenever I need them. And pixel x will do this, return that mapping, and pixel y will return that other mapping. There we go. And then I can just get those values here and get those values here. This should be the same, but at least I took that mapping and put it into its separate function. That way when I need it here, I can say t.pixelx and point.pixelY. So rather than draw the ellipse at that points x and y, I can trigger those pixel x and pixel y functions. Ooh, I like that. That was a nice little addition I had there. Okay, so now we have exactly the same program. Nothing is different, only the I looked at the chat again. Edit this out. Sorry, Mathieu. Edit point. Whenever I look at the chat, I gotta hide the chat. Come on, people. Be nice to each other in the chat. You probably are, and I just see the one word that makes it appear like you might not be nice to each other. I've been doing vocal exercises. I had a lot of sore throat issues this year. They've all gone away. Vocal exercises are really helping. All right, back into the video. What was I saying? This is exactly the same program. The only thing that's different is the points now live in a sort of traditional Cartesian plane, and then I'm mapping those points into the pixel space when I want to draw them. Great, so that's step one of this follow-up video complete. Let's do step two. So what is step two? I want to change, what I want to change here is this. If x is greater than y, I want to be able to have, let's come over here, any particular function. So I could say y equals 3x plus plus 2, right? That would mean if x is 0, then then y is going to be at 2. If x is 1, y is going to be at 5. So you can see this is that particular line. So I want to be able to train the perceptron to recognize this versus this. And I want to be able to change this formula. I can make it negative 2x minus 3.7. I want to be able to have any generic formula for a line work with this example. So let's add that into the code. So I think the easiest thing for me to do, and I'm just going to put it in this tab, is to write a function. I'm going to call it, it's going to return a float, and I'm actually just going to call it f. Is that like a terrible thing to do? F of x being the function for, maybe I'll call this like line, whatever. I'm going to call it f of x. And I'm going to say return, what did I say? 3 times x plus 2. So this function basically represents the formula for the line. And I'm going to say y equals mx plus b, right? That's the formula for a line. We've seen this in other, so funny how all these examples have this like two-dimensional space with a line in it, because this is the simplest way to start working with data and visualizing that data. But ultimately, as I get further along in these machine learning examples, we're going to have these n-dimensional spaces that we can't even fathom or visualize. Okay. So now the one thing that's a little bit of an issue with this is my mapping is between -1 and 1 and -1 and 1. I want to make sure the line isn't kind of off and out of our view. So what I'm actually going to do is I'm going to have this be 0.3 times x plus 0.8. Again, I could have changed the mapping to between -10 and 10, but I kind of like this idea of between -1 and 1 for whatever reason. So I'm going to change it to that. And now what I'm going to do, I at least just want to draw that line. So I'm actually not going to change any of the code in this example. I'm just going to see, can I draw that line? So this is where I previously drew the line. So what I want to do is I want to draw a line from where? I want to get the y value for when x is -1 and the y value for when x is 1. And then I can draw a line between those 2 points. So, okay, so I'm going to say -1, f, so I'm just going to say x equals -1, y equals f of x. And this is x1, y1. And then the second point is x equals +1, and y equals f of x2, y2 is f of x2. So I'm going to draw a line from x1, y1 to x2, y2. And this is perhaps a very long-winded way of writing this, but just to see, what I'm using is that formula for a line to get the corresponding y to a certain x. Okay, let me run this. What's wrong with this function? Oh, whoops, I have to say float x. I lived in JavaScript land for a second. I must set the type for that variable. Probably everybody in the chat was probably shouting at me about that. Okay, where's the line? I don't see it. Why don't I see that line? Guess what? Guess what I forgot? I have to do that mapping. All right, everybody, settle down. I'm gonna do it. I'm gonna reuse that pixel y. So I'm going to say point P1 equals a new point, which is at -1, f of -1. I'm going to write this in a bit of a crazy way. P2 is a new point. New point between at 1, f of 1. Okay? And then I'm going to draw the line from P1 pixel x. Can I please type today? P1 pixel x, fast forward this part, I'm typing here. P1 pixel y, and then P2 pixel x, P2 pixel y. But look at this. Why am I getting an error here? I want to make a point at a specific x and y. What does point do? What does the point object do? I can make a point at a random point, but I can't seem to make one at a specific point. Well, guess what? Guess what? In Java, processing is Java, you can do something called overloading. It just so happens that I'm going to cover overloading, constructor overloading in this case. I can say I want to have another way of creating a point. And I'm going to use the underscore, kind of ugly underscore notation. But what I want to do is have some arguments to the constructor. I don't want to call them x, y, because the point objects variables are x and y. So I'll call them x underscore. And that's going to be a way that I can do this. I could also figure out the label, but I'm not going to worry about the label in this case because I'm not labeling these points. I'm using them just to draw the line. Okay, so now that went away and I should be able to, there's that line. So there's the line. Boy, this was a lot of work just to draw that one line. And you can see though, I can change the formula for the line if I say, minus -0.2, now the line is further down. If I say minus 0.3, now the line is pointing the other direction. So I can now create any formula for the line and visualize that in the window. Time out. New constructor, don't forget about confirm. Oh, look at this. The chat, Simon and Alka are both pointing out all the things I missed while I'm doing it. But I got them. I did okay, right? How am I doing so far time-wise? I'm taking a little pause here. This will get edited out. And the next thing I'm going to do is now I have to add that formula into calculating the label. 14 minutes or so. Okay. I wonder how many different parts I should do. Equation parser. Ooh, an equation parser and allow a string to make any equation work. Ooh, I like this. Everybody's requesting stuff in the chat. Whenever I use processing, everybody in the chat says, can we use JavaScript? Can we use JavaScript? Then every time I'm using JavaScript, how come there's no processing? How come there's no processing? I can't keep it all together, folks. I'm trying. Okay. All right. I'm coming back into the video. Okay, so now, what's going on here? So now that I have this formula for the line, I need to change this. No longer do I want to check just is x greater than y. How do I determine, and I'm looking for my eraser, how do I determine whether a given point is above or below a line? So let's say I have this line, and the line is y equals 3x plus 2. I know it should be, all right, let me try to be more accurate about this. I'm going to point it up more. And I have some point. So let's say I have this is the Cartesian plane here. Oh, I'm kind of drawing this as a mess. Okay, so let's say I have the point x. X is 3. So if x is 3, then this point is 3, 11. Right? I think because 3 times 3 is 9 plus 2 is 11. So if I had the point 3, 12, it's above if the y is greater than the y that would be on the line. And if I have the point like 3, 3, it's below if the y is less than the y that would be on the line. So I can do that for any value of x. So if I take any value of x, all I need to do is calculate the point that's on the line and see whether it's greater than or less than. So let's add that into the code. So here what I want to do is I want to say, I'm going to say line y equals f of x, right? I'm going to calculate the actual y value for this particular x on the line. Then all I need to do is ask, is the y value above it? Then it's a 1. Or is it below it? Then it's a -1. So hey, that was easy. That's done now. And there we go. So we should be able to see this perceptron over time learning to figure out whether points are above or below that line. It's a little bit stuck right now. You can see that it's, and this probably has to do with learning rate and how it started, how the initial weights were started. But so I want to kind of figure out why is it kind of stuck? So there's another thing I really would like to do here, which is visualize what the perceptron currently thinks is the line. And so what do I mean by what the perceptron currently thinks? Well, remember, the perceptron is, oh, did I not add the bias to this? Oh, whoops. Oh, whoops. Oops. No wonder it can't do it. Did I talk about does anybody remember? Does anybody remember last time? I think I talked about the bias, but I don't think it's in the edited video that was published. Right? Oh, sorry, Topher J, who lost power at the office. I talked about the bias in the live stream, but I didn't, so I have to fix that. All right, we're going to fix this. You talked about it but didn't implement it. Yeah, but the question is, did I talk about it in the edited version of the video that's published? It's one thing to talk about it in the stream, but people later don't watch very few people watch the archive stream. They generally watch the edited versions. So if I go, I'm talking about what's in this particular video here, which is 45 minutes. Hey, no extra ads. No extra ads. All right, maybe okay. Right, towards the end here. Input 1 is y. Oh, I can't watch myself. This is very uncomfortable. I'm really working through the same problem that's from my linear regression. Oh God, I'm really, can you guys really stand listening to me? Oh my God. I don't see anything about the bias in here. Oh wait, no. It's there. I must have talked about it, right? I must have talked about it, right? Yeah, I did in the edited video because it's there. Okay, yeah, there we go. Okay, I'm touching my nose, I'm listening to myself, I'm saying, okay. All the nervous tics are coming out. Yeah. So why is this here's the reason why this is getting stuck. And I mentioned it in the previous coding challenge, and I completely forgot about it until now, the bias. So let's talk about why does there need to be a bias. Here's the thing. Let's consider the point 0, 0. When I say, this is the point 0, 0, y equals 0 times x plus 2, the corresponding y value is 2. So 0 is below the line. Here's the thing, with my perceptron, as I send in the x value and the y value, if I send in 0, 0, no matter what these weights are, if I multiply the inputs by the weights and sum them, I'm always going to get a 0 coming out, which can't be right. And this actually, in this formula for a line, y equals mx plus b, these weights are actually describing the rise and the run. Those are the right terms of the line. The slope, the numerator and the denominator. You can almost think of this as, I think, weight 1 divided by weight 2 times x plus b for bias. The bias being the y-intercept of that line. Where is it? So what the bias is in a perceptron is another input that always has the value of 1, but has its own weight. You can call it the bias weight. And now you can think of this formula as y equals weight for y divided by weight for x. Or is it the other way around? Somebody's going to tell me in the chat. Times x plus weight for the bias times 1. So hard, this is sort of times x. Does this make sense? So this is really what the perceptron is learning. We know the formula for the line, and we could do all this with maths. However, we can train a neural network system, a perceptron, to figure out the formula for this function. The idea of neural networks are to solve a function. How's the best way to say this? Time out for a second. I need some wording. Example formula, I'm looking at the chat. Yeah, okay. This is just the beginning of using neural networks. We are using a neural network, a simple perceptron, to figure out the formula for a line, the function, to get a y with a given, to get an output with a given set of inputs. But what if those inputs are, there's 1,000 inputs, and we can't figure out what should really, we don't have the math formula for a line, but we'll be able to use a neural network in the same way to solve that function. That's not the right way to say it either. I'm like losing my confidence here. I'm going to try this one more time. Neural network is something that can make its own functions. That's what I'm trying to say. Universal function approximator. Thank you. Roll this back. Roll the tape back. M is slope with increasing value of x. What is the value of coordinate y? Oh, we're gonna find out if this is right. Okay. A neural network is often referred to as a universal function approximator. Thank you to the chat who just posted that terminology, right? With a simple two-dimensional space and a formula for a line, we can do the math directly. But here, you can imagine once our data input set once we have all this data with lots and lots of inputs beyond that are in n-dimensional space, we want to be able to approximate a function to work with that data. And we're seeing this beginnings of that here. Okay, so let's go now and implement the bias in the code. And I heard the camera just shut off, so I'm going to press that. All right, so for the bias, there's a couple things I want to do. Number one is I'm just going to add that to the point. I'm going to say it has float b for bias. Let's just call it bias. And bias is always equal to 1. So every point is going to have an x and y and a bias. And then the perceptron now needs to have 3 weights. Needs to have the weights for the 2 inputs, the x and y and the bias. And one thing I might do is give the perceptron constructor a number of arguments so that we could have a sort of more generic perceptron, and I can say weights equals new float n. And then when I create the perceptron, I want to say perceptron 3. And then here, this was just something I had just to test the code. Now the inputs should always be an array of 3 things. And is there another here, training? I should always make sure to include that bias. And I think, did I miss it anywhere else? I hope I didn't. Let's find out. Is it working? So here's the other thing. I can't really tell if it's working or not. It does still seem to be stuck. So I probably missed something. And I should go through and debug this. But I think everything is actually right, because the inputs I is still the bias, which is 1. Hold on, timeout. This is going to be edited out. I'm just thinking for a second. This is bothering me. I think what I want. Yeah, I just got unlucky. I just got unlucky the last time. So it actually is working. All right, let me come back. So I'm going to go back to where I just Change that. I think I was able to get all of the, and so let's run this again. We can see that it's still a little bit stuck. I'm pretty sure that I have the correct code now. But here's a way that I'm going to be able to determine whether it's working or not. What I want to do now is also visualize what the Perceptron currently thinks is the line. So remember, this is where I drew the actual line, the correct formula for the line. What I want to do now is, I think I could do this with the Perceptron. So I can say point P1 equals new point -1, and I'm going to say, what did I call the Perceptron? Brain. Brain dot guess y, -1. So I'm going to ask and P2 is 1, brain dot guess y, and then I'm going to draw the line, let's call this P3 and P4. So I am going to attempt to draw the version of the line that the Perceptron thinks, and this should be 1. So now if I go into the Perceptron, and I say, I already have a function called guess. Guess y. It's a little bit awkward here naming-wise. Guess y. And I have an x value. The formula for the line, so the slope should be weights index 0 divided by weights index 1. And the y-intercept should be weights index 2. So I should return m times x plus b. So something's happening here, but I think I'm off, right? Maybe what I meant to say was weights 1 divided by weights 0. So this is the line trying to learn. Boy, it's really not doing a very good job. Let's run this again. It's getting stuck, right? I have to... annealing. Minzkraut is asking about reducing the learning rate over time, which I was thinking of doing. Let me step out of the tutorial for a second and give myself a lower learning rate. Yeah, I think I definitely have something off. Hold on, I've got to... let's look at I kind of want to look at the... let's think about this. Thinking here. I'm waiting at the chat for... am I converting to pixel space? I think I am, yes, right? Let's look at what those... let me go back to... let me go back to this way. This is like where I need to play this music. This is my debugging music. It's funny because it looks like correct there, but just flipped, right? W1 divided by 0 times x. Did I not? Yeah, I did that. It should be W1. I knew that's what it should be. I'm looking at the chat. Yeah, I know I need to. There's so many things I want to add to this. I was just trying to get this one. I guess I'm gonna do what I didn't want to do, but there's no reason not to. I'm just gonna go look at my example that I made a long time ago and see what I did there. So this is my example from a long time ago that you can see that it's behaving more like you would expect. So let's see. Let's look at some of this. So in this example, I made an xmin, xmax. I made a coordinate space that has, I have this like tiny learning rate. 3, training, okay, same sort of deal here. And I draw the line. Now, get the weights. I don't know what's going on here with this because I'm trying to probably convert it to pixels here. This is the right idea. 0 divided by 1. So this one I did 0 divided by 1. Oh yeah, formula is, there's a way to figure this out, of course. All of these should add up to 0, right? Hold on, let me take a little break here, right? Whoops. All of these, weights 0 times x plus weights 1 times y plus weights 2 times b. All of this, I know I'm off, you can't see anymore, equals 0. Sorry about that. Here, let me turn the camera. And so I can say, let me just write it this way. Weight 1 times x, plus weight 0 times x, plus weight 1 times y, plus weight 2 times b. All this should equal 0. So y equals, oh yeah, look at this. Oh, so, I'm going to put this in the video. Because this is where my mistake is happening. All right. We minimize this. All right, so I think I need to take a closer look at this and figure out if this is really right. I was just kind of trying to guess. So there's a way we can actually do the math for that properly. Remember the perceptron, right? The x is multiplied by a weight, the y is multiplied by a weight, the bias is multiplied by a weight. All those are summed. So the formula for the line that it's learning is actually the 0 weight times x plus weight index 1 times y plus weight index 2 times b. All of this should equal 0. So that means weight index 1 times y should be weight index 2 times b minus weight index 0 times x. And then y should equal weight 2 divided by weight 1 times b minus weight 0 divided by weight 1 times x. I think that's right. That's pretty different than what I have. Let's take a look. Oh, there's a major error here. Even before I got to this, thank you to Ethan Elliott in the chat. I forgot to initialize the bias in this constructor. What a disaster. So probably do save me from myself. I'm just going to initialize it up there. I wonder, that's really going to, so I never actually even had a bias. So I think this is actually working, but I'm not visualizing this line perhaps correctly. So let's go back now and let's see, where do I want to do that? I'm going to say y equals, so let me use the formula that I just used. Return, so let me do this. I'm just going to create some shorter variable names to make this easier to look at. And I'm going to say return, I'm looking over here at that formula I wrote over here. I'm going to say return W2 divided by W1 times B times bias. Oh, times 1. The bias is always 1. So W2 divided by 1 plus W0 divided by W1 times that x value. Now let's take a look and see now if things are working as they perhaps should. I think you can see that it's actually, I've flipped somewhere. Am I missing a negative? Oh, this should be negative. That's why. And minus W2. I'm just curious here. What if I take this out? I just... bear with me. This could be edited out, this part here. Hold on. Let me go back and look. Negative weight 2 minus weight 0 times x. So why did I... All right, what... hold on. Should this be negative? That should be negative 2. No. Well, clearly it should be. Why is that negative also? So this is where I left off. Right, you can see that it's in the wrong place, but it's learning. My first two equations on the whiteboard weren't equivalent. Oh! Oh, this should be negative. I'm making a lot of mistakes today. It's very hard to do this live on YouTube. Although I'm sure lots of other people wouldn't make as many mistakes as me. It's because I'm only having tea. All right. Mathieu, I am so sorry. You can go way back to where I switched this to negative. This looks very close, but it's kind of off, right? Thank you to the chat. Somebody in the chat just told me that my equations are wrong, and they are. This should be negative, right? Because all of these add up to 0, so I need to take, to make this equivalent, y1 times y equals negative y, w2, w1 times y equals negative w2 minus negative w0x. Oh, that's going to fix it. Okay, so now I'm going to say negative here, and we're going to run this, and we're going to watch the perceptron over time, and you can see as it's correcting, all those circles are turning green with this learning rate. Slowly over time, the line is converging to the correct spot. Perceptron learn the line. So, you know, there's going to be a part 3 and a part 4 to this because I think I'm going to wrap up this particular video. There were some other things that I wanted to add to this. But at least now in this video, I've added the bias. I've made it so that I have a Cartesian space I can work with, and I can work with any formula for a line. As you can see, life is just one big refactoring. And there's so many things I could do to refactor this. And visually, I still don't necessarily love what I have here in terms of explaining what's going on. But at least now, let's just, before I go, let's make a new formula. Shout out your numbers to me. Nobody can shout out to me. 8, 9 times x plus 0.2. Or let's do minus 0.2, minus 0.1. Let's just have a different formula for a line and see that this, again, works. We can also probably have a much better sense of what learning rate is doing. Like, look what happens if I make the learning rate 0.2 right now. You can see how it makes these very large movements. So it gets to the correct answer very quickly, but it can't kind of do the fine detail to really find the correct spot. And if I make the learning rate really ridiculously small, you know, you can't even see. I mean, it is, in theory, this line is moving. It's so small that I can't even see it. Let's not be so crazy. Let's do that. I can't even find the line. The line currently isn't even in the space, because remember, it starts with something random. Let's run this again. So this line is moving, but it's just really, really, really slow. So it's all about finding, and that learning rate can change over time. I could start with a large learning rate. I should make a slider to adjust the learning rate. I could start with a large learning rate so it gets close. Look at that. locked right in. And then I could lower the learning rate for those refined movements. Okay, so I have a couple things I want to do. I think I'm going to make a couple follow-up videos on this. They'll appear at some point. But there was a great comment in the original first version of the coding challenge about adding data that is not part of the training set, which of course is very important in machine learning. So I'm going to do that in the next follow-up to this Perceptron coding challenge. Thanks for continuing to watch. Okay, yeah, get in Discord and you can shout at me. All right. Yeah, you could change the... Boy, that I really... Yes, follow-up of the follow-up videos. All right, so what am I doing? How am I doing time-wise? I used up my first hour. So I wonder if I should move to my Frogger refactoring. Let me at least show you what this comment was. I pinned it. If I go back to the Perceptron. What happens if I Google Perceptron Shiftman? What's the chance? There it is. What is this? 2006. Whoa. Is this really going to come up? This is from over 10 years ago. Oh my God. You were just destined to repeat yourself every 10 years with new languages and frameworks. Long overdue. This is from 2006, apparently. I've started working on a series of processing examples that implement neural networks. Yes, I spent some quality time with Artificial Intelligence by George Luger. I've used that book, I suppose. Look at this. I originally did these. Ooh, Aaron Steed's website. What's this? Look at this. Artificial Intelligence Libraries for Processing or Java. Wow. Does this still exist? This is amazing. Okay, I will take my little tour through creative coding history later. I think that I should try to do the Frogger refactoring. Let me, sorry, I got sidetracked. Oh, I wanted to get to the Perceptron. Oh, I wanted to show, too much to do. Let me get to this. So I pinned this comment. Oh my God, another ad. Who puts these ads? Why do I put ads on my videos? It's not like I'm really making any money off of them anyway. Okay, how did I mute this? Oh, there we go. Okay. I should click on the ad and make 2 cents or whatever. All right. So let me read this comment. One thing you should definitely do is try your Perceptron with new data. You can create another 100 points, exclude these points from training, and test the Perceptron with these points. A cool way to test is add a point at the click of the mouse and let it label it from the Perceptron, and then some nice feedback. So I wanted to do, this is the next thing I wanted to do. Of course, this could be a great exercise for anybody watching. Just get an ad blocker. No, I can't get an ad blocker because I support ad, I don't know what I'm talking about. Okay. And so, or YouTube Red. Actually, I should sign up for YouTube Red. That I should do. Because I like to support people on YouTube. Trying to do stuff. Look, here's another, okay, I'm looking at these suggested videos and like, oh, which one should I watch right now? All right, I'm distracted. So, how do people feel, oh, don't click on your own ads, that is illegal. Okay, I shall not click on my own ads. I hereby affirm, I don't want to swear, I affirm on the Million Random Digits book. Do you, Daniel Schiefman, solemnly affirm on the 1,000,000 random digits with 100,000 normal deviates from the RAND Corporation that you shall not click on your own ads? I do so affirm. My fingers are crossed. I'm just kidding. Okay. Okay. So let's do a straw poll. Maybe I shouldn't. I should just... Yeah, so I think Simon is asking that the line is off. And it's never, I don't have enough training data, nor am I refining the learning rate in such a way that it's ever going to be perfectly precise. I do believe that the Perceptron would work and get a perfectly precise line if I, for example, a couple ways I could do that is if I had many, many more training points. So now I have 1,000 training points. So we can see it learning over time to correct its guesses. And if I did something where eventually, like I did something where I think it's called annealing, where I changed the learning rate over time. So I could start with a high learning rate and then lower that learning rate to refine and kind of get it exactly in position. I do. You may now kiss the book. Yeah, did I just marry the Million Random Digits books? Because that's a little bit weird. All right. What do you guys think? I'm trying to decide if I want to do more with the Perceptron or I feel like I want to refactor the Frogger because I'm not going to be back for a while. And I feel like I can't let that Frogger code stand. I mean, trust me, I'm all about just make it work, messy code, have fun, don't worry about it too much. But I do feel like, yeah. So yeah, Simon, that would be a great exercise. David in the chat asks, is Daniel a professor or a teaching assistant? Unfortunately, they somehow gave me some sort of professor-like title here, but really, I'm like, whatever's lower than a teaching assistant, I think that works for me just fine. Okay, so I'm gonna go to Frogger. Let's open up Frogger. I want to show, by the way, somebody on Twitter shared with me. I want to say, if you're going to share stuff with me on Twitter, please share it to @Schiffman. I don't really check the Coding Train's Twitter, but I did check it. It just auto-posts stuff from YouTube, but I did check it right before, because I have it on this login for live streaming. And @Jason Ma on Twitter created, and there's a GIF of it here, a version of the Frogger game that based on the code that I made. You could see added colors and different sizes and speeds and multiple lanes, score and a timer and all that stuff. It's a great example. All right, and then I wrote, I replied from @Schiffman because that's what I'm better at doing. Okay, so let's see, where did we leave this at? So this was Frogger. Let's see if I can at least defeat it once. Come on. Got it? Yay! You just watched me play my own game of Frogger. So now I'm going to, so what I would like to do is I'm going to do a refactoring video. The main issues, I mean, there's so many things that could be improved, but this is a major problem, this hard coding of all of these different objects. So I think the other thing is this log class I discovered was unnecessary. So I'm going to just rename this to obstacle. So a car and a log are different kinds of obstacles. They can just both be an obstacle object. Then I'm going to create a lane class. And so I will configure a bunch of different lanes. And each lane will have the color of the vehicle, the speed of the vehicle, maybe the type. There's a variety of different ways that I could approach this. So that's what I am going to do. I think it would be better if the frog would snap the log it lands on, but if it's too far off of the log, it would fall into the water. That is a good idea, Alka. So I think my approach here is more to refactor the code and not necessarily improve the gameplay, although that would be useful for another video as well. But I'm not going to add score and that kind of. I just want to make the code easier to work with. I should calculate the learning rate using the error. Be better than the number of iterations. That is a very good point about the Perceptron. I should mention that. Can somebody somehow, hold on, I was keeping a text file. Is it open still? Open recent, untitled maybe? No. So sometimes I try to keep notes for next time. Next time, Perceptron, learning rate tied to error. Data that is not part of training set. Visualize, these were the other things I wanted to do. Visualize the Perceptron itself. And then, why is one Perceptron no good? So these are the things I didn't get to today. Add the momentum. I'm sorry, I'm reading the, oh, there's all sorts of stuff going on in the chat. All right, yeah, we're going to add color. I'm going to add color in this because the lanes can have a color, I think, even if it's just sort of random. Okay, so here we go. I don't know why I'm playing the timpani sound. It's my favorite sound effect that I have. What time is it? I have 45 minutes. So whatever happens, happens in this 45 minutes. This timpani sound is still going. It's almost over. Hello, I am back for another Frogger video. So this is, I guess, part 4 at this point of the Frogger coding challenge. And in some ways this was unnecessary. But I do feel like the first 3 parts were a demonstration of what happens when you just try to figure out stuff from the fly and you're kind of rushing. Do not play this game for 45 minutes, please. Hello, welcome to what is now somehow part 4 of my Frogger coding challenge series of making the game Frogger. So at the end of part 3, I have this kind of version of the game that I can actually play here, and I'm in a second I'm going to get to the top. Yay! So what I want to do, though, so here's the thing. I think the first 3 parts were in some ways an illustration. An example of what happens when you rush through code, you're trying to figure out stuff on the fly and things start to get very messy. I'm like, oh, I'll fix this later. And I try, don't get me wrong, I'm all for messy code and just having fun and trying what works. But I do think this is an opportunity for me in my videos to take a look at what it means to refactor code. So what I would like to do in this video is change very little, really. At the end of this video, I would be happy if what you see is exactly this result. But the code has been rewritten in such a way that it's a bit more scalable. Right now, if I wanted to make the window taller and add more log lanes or more car lanes, I'm going to have a very difficult time doing that. A lot of stuff was hard-coded in here. So the main work that I'm going to do, and again, I haven't really done this before or planned this out. I'm just going to be doing this on the fly as well, so I'm sure I'll create new problems by solving older problems, is create a lane object. So let me think about this for a second. So I need to do timeout because I want to use the whiteboard. And I haven't played the This Dot song today. Do people want to hear the This Dot song today? That's usually what I play when I erase the whiteboard. Where is it? As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. This was going to be so cool when I... This dot, this dot. Oh no! This dot, this dot. It's okay, that cup of tea was empty and it did not spill all over my laptop. This dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot, this dot, son. This dot, this dot, this dot. Never forget this dot. All right, so now I'm going to pretend that didn't happen. And the frog, a unicorn, and the lane's rainbow colored, definitely. Okay, so now I'm going to go over to the whiteboard. Okay. So let's think about what is a part of the lane. So if this is the Frogger game, an individual lane has a bunch of elements to it. It actually could be an instance of a rectangle object. Right? It could also extend rectangle because it can have an x, y, and a width and a height. But ultimately, the things that I want to keep track of are number of cars or logs, speed of those cars and logs, spacing of those cars or logs. So a lane is going to keep track of all of those things on its own. And it could also, what else could it have? It could have like a color for the cars, a color for the background. So you can start to see like what are all the things that are part of an individual lane. And another thing, thank you to Me I Am So Me who suggested this. You might have noticed in my previous example that the cars and logs are actually basically identical. I'm just drawing them in a different way, and ultimately, I'm actually not even drawing them in a different way. That's something that's still sort of like left as a next step for this program. But I'm interacting with them in a different way, in that I'm checking whether with the logs, the frog has to land on it. With the cars, the frog has to avoid it. But I think I could just use one object and just call it an obstacle, rather than have these two different objects. Is kind of unnecessary at this point. Okay. So coming back over here, let's start trying to do this. So let's try to write some code for the lane class. So class lane. Oh yeah, and Simon is asking in the chat, what about the safety lane? So that's an interesting question. I could just have a lane that has a number of obstacles as 0. That could be how I indicate if it's a safety lane. And I could also, there's something else I was thinking of here. I could also have some sort of like a type variable, whether the lane is like a cars lane or a logs lane. And the logs could be turtles, right? And the cars could be cars or trucks. There's a lot of possibilities here. And again, I'm just trying to do a small, simple version of this. So coming back, let's create this lane class. And let's get rid of, I hesitate to do this. You know what I'm going to do? I'm going to save this as, oh, wait a second. Oh, yeah, no. Save this as Frogger2. And I'm going to delete the log class. Get rid of that completely. It's going to break. I'm going to call, and I'm going to change this to rename. By the way, this is something that's in processing now. I'll see if this works. If I go and use rename, I can rename it to obstacle, and it's going to change it everywhere in the code. So see how well that did. Attach, so one place where I missed it here, because obstacle. So I missed it there. Okay, so this should still be, and this should be obstacle. And this should be, I missed it by not changing log everywhere. So many places. Oh, come on. See, this is why my code is terrible. Oh, God. Okay, so now I have at least the same program again, and just obstacle instead of cars or logs. Now, back to the lane. So what I want to have is I want to have some array of obstacles. What else did I say? I want to have a speed. And maybe I said maybe I want this to extend a rectangle, so I can have a location. I want it to have a I'm looking here. A speed, what else did I say? Spacing, sorry, and a spacing. Let's just do that for right now. Let's start off simple. So in the constructor, this should say extends, the constructor should have a number of obstacles, SPD for speed, and SPC for spacing. So obstacles now is a new array of obstacles with n elements in it, and speed is some speed, and spacing is some, and spacing is some spacing. Okay? So this is the idea of a lane. And if it extends a rectangle, I also need to call super, and I probably should give it an x, a y, and a width, and a height. X, y, width, height. So this is a lot of stuff to pass in. An x, a y, a width, and a height. I'm sorry, I spaced out for a second because this camera clicked. This is a lot of stuff for the constructor. I don't love that. Might want to rethink that a little bit later, but I'm going to just leave that for right now. Okay. So now what I'm going to do is I want to get rid of all this nonsense. So I'm going to comment all, actually I'm just going to delete it. I'm just going to leave row 1. Just going to leave row 1 and I'm going to get rid of this. The idea here is that instead of having two different arrays of obstacles, I want to have an array of lanes. Now, how do I know how many lanes I need? Well, actually, the way that I'm going to do this is I'm going to have a lane object for every single horizontal bar, even the beginning bar, that middle safety lane, and the end, for example. So if I know the height in pixels, I could just say the height divided by that grid size is the number of lanes that I need. So I'm going to say lanes equals a new array of lane objects with total lanes is height divided by grid. And I want that to be an integer, so I'm going to convert that to an integer. Total lanes. Okay, we're getting somewhere. Refactoring. Very exciting. So I want to have a total number of lanes. And here's the thing, actually, Simon in the chat is making a good suggestion. I can really simplify this. I actually don't need to pass in an x. I don't need to pass in a width or a height. Because the x is always going to be 0, the width is always going to be the width of the window, and the height is always going to be that grid size. So I can create its rectangle with some hard-coded values, and I feel perfectly happy with doing that. And there might be some reason I have to change that another time, but that makes this much easier to read. Okay, so this is the total number of lanes. Now what I want to do is I want to loop through and create all of the lanes. So for every single lane, what do I need? I need the y position, the number of obstacles, speed, and spacing. So let's just pretend for a second that what I'm going to do is just put cars on all the lanes. I'm going to say a new lane at I times grid, right? So I times grid is 0 times grid is 0, 1 times grid is grid, 2 times grid is 2 times grid. So 0, 50, 100, 150. So that's going to give me all the spots. And I'm going to just put, what is the next thing I need in the lane? The number, I'm going to put 3 objects in each one. Then I'm going to, then the next thing is the speed. I'm going to have all the speeds be 1. And the spacing is going to be 100. So I'm just kind of going to do this in an arbitrary way. I'm going to delete this. And what I'm going to do now is I'm going to comment everything out. because we're going to have to figure this out now. Everything's going to get much better now. So this stuff, so what I want to do now is I want to loop through for every lane in lanes. Let's say lane.show. So I want all the lanes to show. So that means I need to write a show function. And what does that show function say? For all the obstacles, have them show. And by the way, here when I made this array, I kind of need to create all those obstacles. So now I need to say obstacles dot index I equals a new obstacle. Whew, boy, isn't watching somebody refactor their code wildly entertaining? Oh my goodness, I'm not sure this was such a good idea. So what is it when I make an obstacle? I did that. I deleted all that stuff. I needed to keep that because I needed to reference it. But it's okay, I can remember. I give it an x, a y, a width, and a height, and a speed. So the obstacles get created at, where do I do that? In the lane, they get an x. The x is I plus, the x is spacing times I, comma, the y is the lane's y. Then what else? The speed is the lane speed. And width and height is, that's okay. Okay, I'm just going to make them squares right now. Grid, comma, grid. I forgot about something. Okay, so we're going to fix all this. What do I have so far? One RUD. Okay, hold on. Just take a break for a second. I'm like, my brain is starting to, gotta stay hydrated, I think. Wait, everybody's saying same in the chat. I have to know what this is that they're saying. Oh, everybody's saying the stream lagged. Am I still here? Am I back? Okay, just lagged for a second. Okay. All right. Okay, here we go. Let's keep doing this. Why don't I see anything? I probably forgot something rather important. I made a bunch of lanes. So let's debug this, and let's just see how many lanes did I make. Let's make sure I'm making a lane. Put a print. Yeah, okay, I made 10 lanes. That's right. Each lane, did I make the obstacles here? Looks like I'm making the obstacles. Oh, am I calling the show function? Lane show. So let's see, obstacle.show, obstacle.show. So what's wrong here? Let's just see. So it should be drawing a bunch of things. Ah, look at this. The width is 1. I messed up the width somewhere. Okay. New obstacle. Speed is the last argument. Right? The obstacle requires x, y with height speed. X, Y with height speed. Okay, so I made a bunch of lanes. That worked. Now let's, I've gone a few steps backwards here, unfortunately, but we're going to get back to what we had. This is going to be good. Trust me. Stay with me here, please. Stay with me. Let's say lane.update. What was it? This is not update? No. Oh, yeah. Oh, I should just make a run function. Let's just make it run. I might regret this later, and we'll do show update. So lane.run. Okay, so all the lanes are working. Now they're all doing exactly the same thing. That's fine. Is it going to come back? Yes, they're coming back. Okay, so this is good. My lanes are working. One thing I realized I forgot is that the lanes could use a variable for how wide so when I create a lane, what do I have right now? I have its Y position, total obstacles, speed, and spacing. You know, one thing I sort of feel like doing is maybe just making the speed random. I mean, why not, right? So I have fewer arguments. Let's make the speed random, somewhere between like -3 and 3. You know, let's just, so I don't need a speed. So that's sort of nice to see, right? So even just with the speed random, I'm going to get a lot of kind of variation there. And it could be hard. There could be a specific configuration it's supposed to be, but I'm going to make that random. Then I'm also going to, what I want then as another argument is the total number of vehicles and the size of those vehicles, the width. So I'm going to give it a variable called W. Does that mess things up though? Because it extends rectangle. So I don't want that. So what is it? I'm going to call it the length. So this is the length of the cars or logs. And that can actually be an integer, because I'm going to think of it as they all have to be a certain number of cells on the grid, a multiple of 50. So now when I create the lanes, I'm going to, and I'm actually, could just make that random also. But no, you know what, I might end up, let's just put 1 in there. I'm going to do this. You'll see, hold on, I got an idea here. So I'm going to put 1 in there. And then the obstacles, their width is grid times that length. And guess what? I don't think I need to actually keep track of these variables. Well, speed I do because it's random. Like I don't really need to keep track of this spacing. Anyway, I'm really just using it to initialize, but that's fine. Okay, so now look at this. That's with 1. And I've got all this nonsense print line in here, stuff that I don't need. Where did I put that print line that I don't need? Now, what if I say that 2? Great. So now you can see they're all double wide. And this spacing, I could make 200. And you can see now they're all spaced out by 200. They're all double wide. So now I have this ability to just put, as many or as few things. There's only 1 thing in each lane. There's 3 things in each lane, always with a random speed. So I'm hard coding the number of things, their width, and their spacing, but I'm making their speed random. And I'm also going to add one more random thing, which is just a little offset so they don't all start together. I'm going to create a variable called offset. Again, doesn't really have to be, I can really just use this as a local variable here. And I don't really need this, same thing with the spacing. This can just be spacing. I'm going to give it a random offset between 0 and 200, just as giving it an offset. So what I mean by that offset is if I don't actually move them, they will all start slightly offset from each other. Okay, now we're cooking. So I'm able to now have all of these different lanes. And I want to give them a color and some other things at some point. That can be an exercise for you. Here's the thing though. What I love about this is I can run all the lanes, but I still think on some level I want to manually configure them. So it's nice that I can initialize them in the loop and I can make them random, but just for demonstration purposes right now, I'm going to configure them. One at a time. So lane 0 has 0 things in it, so the speed and spacing can be 0. That is where the frog starts. Lane 1, which will be at grid spot, is going to have 3 cars in it with, what's the second thing? A width of 1 and an offset of 150. So, okay, so lane, I'm just going to do this now really quickly. Then 2, 3, 4, 2, 3, 4 will also be a safety lane. Then what do I have left? Let's do this again. 5, 6, 7, and 8. I kind of want 4. I think what I would like, so let's make this the height 600. I would like 4 car lanes, safety lane, 4 log lanes, and then a last safety zone. So what did I miss here? Oh no, that's 10. That was right. I don't need to make it 10. 4, 4. No. That's 3. Ah! I do need 11 if I'm going to do 4. Look at this. You know, we've got a little less hard, got some new hard coding, everybody. So let's make this now back to 600. And here we go. What did I get wrong here, people? I should have 11 lanes. Well, that's 12, 550. Oh boy. Ah, right. And now they all need to, oh, this is awkward. This is awkward. And here, I'm going to give them just a lane index. And then what I'm going to do in the lane object itself is set the Y location, and this is really not Y, it's like index times grid, index times grid, and index times grid. Okay, so you can see now, there we go. There are all of the lanes, and I want to make sure they update. And so there we go, all of my lanes. Now I can start to individually configure them. So I can say things like, the second one should have 2 that are triple wide and spaced out by 350 pixels. The third one should have 4 spaced out by 200 that are 1. Then this should have 3 that are 2 spaced out by... Oh, and I don't want the speed to be random, actually, because they really should be like every other one. Oh, and these are the top, actually. So what's first to... So I don't... The random speed is a bad idea. So I'm going to go back to setting the speed manually, because I want to configure this manually. And I'm going to give it... The last argument will be speed. And I'm going to say... negative 2.5, 1, negative 1.7. And then I'll give this one also a 0. I have too many lanes. 2.84. Oh, I could have made it. I could have just had its direction and still have it be random. But I'm going to manually configure this game of Frogger. You can see how negative and then 0. So now we can see, in this one the last lane they need to be spaced out by quite a bit more. So let's space them out by 250. Okay. So there we go. So now I have, and then I want these to change, like this should be 4, and this should be 2, and this should be 1, and this should be 4. And this should be 1 double wide, triple wide, single wide. So there we go. Here's now my game of Frogger. And I can go through it. Now I'm not doing any of the tests. Now I want to give these lanes a color. I think it would be useful to give these lanes a color. The other thing I could do is let's give these lanes a color. And let's make that the last... let's make that the last argument. Color, and actually, you know what I'm going to do? I'm going to do something totally different. I'm going to write a second constructor. Second time today, although this was in a different video that I recorded earlier today, I'm going to use something called constructor overloading. So I'm going to make a constructor that optionally takes a color as its second argument. And I'm going to use that just for all of the three lanes that have no obstacles in it. And I'm going to say, write a new function that has its index, that can really be an integer, and then a color. And it needs to call super, and then it needs to say obstacles equals a new array of obstacles with 0 things in it. I don't want to have any obstacles in this lane. And it's and I'm going to give it each lane is going to have a color, and its color is going to equal C. So in this constructor, the color will equal black. And here I can now, and then when in the run function, I'm going to draw a rectangle. Oh, doesn't rectangle have a show? No, I'm going to create I'm going to just draw a rectangle. I'm going to say fill that color and draw a rectangle at x, y with height. So we can see, there we go. Oh, I love this. Now I have a lane object. I can configure the game lane by lane. So I can create safety lanes with a different color, and I can create lanes with obstacles in them. So now this is exactly the game. The only thing is, none of the actual gameplay is there. So I need to go back and put that gameplay back in. Now I have all that commented out here. I don't need to draw these separately. What I can do here is I can say, I can now look at every lane. So I can say lane.check frog. So I want every lane to check the frog. And that is going to be here. So what I'm going to do is I'm going to take this, okay, show update. This is really what I want to do here. I'm going to take this, and in the lane, I'm going to write a function called check, which gets a frog. And then what I want to do is loop through all of the obstacles. I'm going to call them O. I don't need to show, oops. This is like taking a really long time, and I feel like I'm being very boring. We're almost there, people. Are you still watching? I don't need show and update. That happens somewhere else. And I just want to check if frog intersects that obstacle, reset the game. So I'm just now going to do that as if all of the lanes are obstacles. Okay, see, this stuff should happen really fast now that we've refactored. I should be able to do this stuff really easily. So see, every time I intersect an obstacle, I should get sent back to the bottom, right? Okay, so I'm able to play this game. Now I need to only check, so I need to figure out whether the lane is a log lane or a car lane. So maybe I'll do a type. Let's do a type. Let's say, I could make it a string. That's probably a bad idea. Let's do I'm going to do this in a kind of a goofy way. I'm going to say type. And the lane is also going to get as its second argument, and we'll do that here too. It's going to get a type when I create the lane. So I'm going to say type equals S. Type equals S. I'm going to create some kind of constants. String safety equals safety. String, what other types could be? Car equals car. String, what's the other one? Log equals log. So what I'm going to do is I'm going to create the lanes this way. This one is a safety. This one is a car. car, 4 car lanes. Then I'm going to have another safety lane, a log lane, and another safety lane. Okay, so now we can see here I've added this. Now, I could have just put the strings directly in here, but I made these like separate variables at the top to store the actual strings because, and honestly, I don't want to use strings. I want to use numbers because I don't want to have to remember is 0 or 1. So I want to have a variable, and these I could say in Java, awful Java monster language speak, I would say like final constant int. So I want to make these ints. But I'm just going to be sort of lazy and have them be all capitals and integers. So now what I'm going to do here is this is an integer for a type. I'm going to call it t, just for type. And actually, I don't need to have this argument here. By definition, if it's using this constructor, it is a safety lane. And this should be an integer. And I can take it out of here. So these don't need explicitly to say safety because that's by definition. Right? Just refactoring. Okay, so now what I'm going to do in the lane check function is I'm going to say if type equals car, I'm going to do this. Right? Now, otherwise, if type is a log, what is the thing that I did? I had this like very weird thing where I had to check where it was, but now I don't have to do that. I can just say, take this, all this code here. I'm going to just grab this for right now, and I'm going to put this in here. This was the code for seeing if it's intersecting with any of these frogs, and if it is, attach that particular log. So I renamed some of these variables. And I'm this is all the same code that I worked out the last time. And if it's not, reset the game, although this is a bit of a problem. So I'm going to have to work this out. This is going to have to change because I'm doing it by lane now. So let me take this out for a second. We're going to work that out later. So let's just see right now. This should work. Whoops. Where I should be able to, oh, look at that. Oh, whoa. So I need to get my attach and detach going again. Let me run this again. Whoa, it's already attached. If type equals log. So I wonder if this is happening by accident even for the, yeah, okay, it's not attached. Oh, but it attaches instantly even to that lane. So why is that happening? It shouldn't, right, if the lane is not, and by the way, this can just be here. It shouldn't, right? What am I missing here? Frog intersects O. Why is it automatically attaching in this lane? Oh, these are the logs. Ah, I forgot. Oh my God. That I did this, the top, I'm creating the lanes from the top to the bottom. So these are all the logs, and these are all the cars. I forgot. Okay, so now, right, if I intersect, I've got to get through all these. And now, here's the thing though, it's never going to detach. So I need to get the detaching back in. So how am I going to get the detaching back in? So I need to determine, I think I should have some code. I need a break. Hold on a second. Just take a break for a second and check the time. I only have 10 more minutes. I really have to leave. And I don't have a lot of leeway here. I mean, I maybe have like 5 minutes of leeway, but I don't have a lot of leeway. And this is clearly, but this is the last piece that I need to do. The question is, should I have the frog register which lane it's in and only check that lane, right? Why not just register the frog for which lane it is? Oh, or on move detach. That's a great idea. Every time I move, I should detach. That's a good idea. Okay, so thank you to Alka in the chat, who said, what I was thinking is one option would be to actually have the frog register which lane it's in, because I know which lane it's in based on its Y position, and only check. Instead of, there's not really any good reason for me right now to have all the lanes check the frog. I kind of want to do that, but Alka had a different suggestion, which is just detach every time the frog moves, right? Because if the frog's going to jump, it shouldn't be attached to anything. So I could do, let's try that. That might actually be a really quick fix, but I'm now realizing that this loop for the lanes is kind of unnecessary. I could just pick the one lane that the frog needs to check against. But let's do the detach thing real quick. On move, I'm just going to say frog attach null. So it's always going to detach. I need to start myself in the center, right? So you can see now all of those behaviors are back, and you can see it's, so now I don't have the thing that's telling me to reset the game. So the issue is, and this is why I want the frog to register its lane. The reason why I want the frog to register its lane is because if it's in that log lane and not touching a log, the game needs to reset. So what I'm going to do is I'm going to say, and I still can do the move detach thing, int which lane index equals frogs y divided by grid, right? And an integer version of that. That should give me the index that it's in. Right, let's just see this. Print lane index. It's actually going to have to be inverted, I just realized. Oh no, that's right. 10, 9, 8, 7, 6. So this works. So now that's the only lane I need to check. So I can just say lanes, index, lane index, check frog. So this way, I got to start myself in the middle, so when I'm testing it, this is hard. Okay, I'm starting myself in the middle. The frog's Y location is height divided by 2, maybe, minus grid. Will that put it in the center? Okay. Oh, whoops, that's in the wrong place. Oh, wow. It should just be lanes. Height divided by 2 minus grid divided by 2 is what it should be. Yeah, there we go, sorry. So now I should be able to, so now I should be able to jump around and get pushed off. But I now can go back and in the lane check. If it's not okay, you lost. Reset the game. Okay, woo. So now I should be able to jump around, but if I fall off a log, I reset the game. If I jump into the river, I reset the game. And it's resetting it to the middle because that's where reset is. Okay, whew, I think we refactored this pretty nicely. Somebody made a good point, like, well, why should I have this type variable? Maybe what I should do is use inheritance and have 3 different lane classes: car lane, obstacle lane, safety lane. And actually, that's a very good idea. And I think it could be reasonable to refactor this yet again. So I think this is going to be enough refactoring for this particular video. All I did was refactor into this lane. And I don't know if you can really see, this makes, if you really want to see the beauty of what I've done, not that anything I've done is really that beautiful, what I love about this now is this is the draw loop. Whoops, I can't use my keyboard. This draw loop is so simple. And the one thing that I would actually say is maybe the lane index, the frog should actually have a function that just returns its lane index. Because look what's happening here. I just run all the lanes. I just check the one lane the frog's in and update and show the frog. So this refactoring, and even though this is a little bit unwieldy, it's so much better. And I think somebody's knocking at the door because maybe I'm being too loud. I imagine somebody knocking at the door. Sorry, Matthew, that's going to be an awkward edit. I'm going to start again here. Even though this is a bit unwieldy, because I've initialized all the lanes manually, and maybe there's a better way of doing the arguments and something should be random, or I should have some type of algorithmic way of generating it, that's yet another opportunity. So with refactoring only comes more refactoring. Refactoring begets refactoring. Life is all just one big refactoring session. So I hope you enjoyed my rather long refactoring session. I think there easily could be a part 5 to this and a part 6. What I want to say is that check this video's, just if you want to contribute to this, there are a few things you can do. So in this video's description, there will be a link to a GitHub repository that has this processing version, that has a JavaScript version of this same code, and then also a link to another GitHub repository that is kind of a community-created version of the game where people can add their own graphics and different things. And if you make your own version and want to link to it in a README, there's all these ways you can share and contribute to this stuff. I need to say it more succinctly, but check the description and I'll describe it in there. So thanks for watching this part 4. Is it the last? Will there be more? Will there be another? Actually, one thing that I was thinking of doing was redoing this whole coding challenge as one video, but in JavaScript. Now that I've done it in 4 parts, maybe I could do it all as one video faster. I don't know. We'll see. I'm thinking about that. If you're interested in that, say in the comments. But I don't know that anybody's actually watched to the end of this video. Okay, thanks for watching, and I'll see you in a future video. Oh, no, don't leave yet. Sorry, one thing. I left. No, I think I might have left. No, I got it right. Oh, no, I left the wrong position. So let's play this game one more time. I gotta win it. My kids just watch people playing video games all day on YouTube, so that's what you're watching now. Oh no, I have to jump on the log. I should add some visual designs, some colors for the lanes to know if it's a river or a street. Okay, I'm gonna make it. Oh no, shoot! Oh no, come on. Maybe speed this up. I made this kind of hard because the last one is so fast. Yay, I win, Frogger. I win the prize of the internet prize. Thanks for watching. I'll see you next time the train pulls into the station. Well, oh, I don't have to do anything. That's just it. Okay. Please clap. That's all I need. Please clap. Did you guys hear a knock too? Alka says, I definitely heard a knocking. Fidget spinner. Oh no, sorry everybody, I really have to go. So this was all I was able to get to today. The things that I missed getting to, I think that could be done with Frogger. Okay, well I could say like, Frogger. There's some really good GIFs that people are posting in the Slack channel. Frogger, what could I do? Redo as one video in JS. And fidget spinner. I wonder what would happen. I've been curious about making a video where I just do a tutorial from my laptop, like wherever I happen to be, without this whole elaborate setup. You know what you usually see. You see the little picture of a webcam of a person in the corner, and then you see the screen, or you just have the disembodied voice. Because then while I'm traveling, I could kind of still make some tutorials. But I don't know, I just like my whole setup here. Oh, and I'm afraid of doing that. But it would be a way of me creating more content while I'm traveling around. Wow, that's really small. I hope the whiteboard is readable. Okay, can I use the Perceptron? So yeah, I mean, all of this, I would love for all of this eventually to come together. And it actually, I have some examples that I've made already for Flappy Bird. That I made one for Flappy Bird, but getting a multi-layered Perceptron to control the frog to win the game is something I think I could do. Okay, so it is 3:29. I will take a few minutes to answer some questions. I'm looking at the Slack channel for patrons, patreon.com/codingtrade, and I'm also looking at the YouTube chat. A table. Play the This Dot song. The This Dot song, I don't think I'm going to play it right now, but you can get it on SoundCloud. Probably if you just search for coding. You might have to search for Coding Rainbow on SoundCloud. Any updates on guest lecture for WebGL? Thank you for asking. I have to admit, I have to confess that I have really been behind on a lot of things, and the things that I've really let slip is scheduling guests. And I said June was going to be my month of guests, but I did this other. So many things have happened that have just made it difficult to make that happen. So I will be working on that while I'm away for a week. I'm going to be doing a lot of emailing to hopefully set up guests for when I come back, and hopefully I'll have one with some WebGL stuff. Yes. Thank you, Nano. I'm glad. Am I a professor teacher at NYU? Yes. So I will answer this question without being silly like I was before. There is a program. It's part of Tisch, New York University Tisch, which is the School of the Arts at Tisch School of the Arts. I was afraid if it's of or for. I really should know that, considering that I've worked here for about Tisch. Tisch School of the Arts. So ITP is a program, let me go back, at Tisch School of the Arts. It is a 2-year graduate program whose mission is to explore, the founder, Red Burns, who is one of my heroes and mentors. She passed away a few years ago, but this is a book of quotes from one of the lectures she would give to the incoming class. And the last quote I read last time was, "If you can resist the temptation to run back to the shelter of your comfort zone." So today's quote from Red will be, "If you permit yourself the intellectual curiosity to explore your differences as you would explore a new city." Actually, these are all ... because I should read these all together because they end with, "You might be pleasantly surprised." Red was ahead of her time. This was like a tweet storm, ... So this is where I teach. I teach full time. I teach 3 classes in the fall, 2 classes in the spring, and I've been making these videos. Ostensibly, I started making these videos as supplemental to my courses, and then I would sort of put them online. And then once I put them on YouTube, a lot of other people found them, and the audience really grew from there. And I've been teaching these live sessions. So NYU has been very generous and helpful with me in setting up this recording studio here. So I make videos, and I also help other people. I've been trying to do more of this at NYU, make videos in the studio, and then I publish them on my channel and use crowdfunding. So in a way, like if you join the Patreon, that's a community where people can ask questions and talk about the code and suggest stuff. That's, it's sort of like the videos are free. I mean, they are ad supported on YouTube, but for a nominal fee, a small fee, you can join a smaller group of discussion and that sort of thing. So I think someone asked, so my next live stream, it's possible that I'll experiment with doing some just content just from my laptop, but my next live stream will be June 22nd or 23rd, Thursday or Friday, and I'll announce that. I'll probably on Twitter at Schiffman, that sort of thing. Yeah. At the beginning I was streaming on Twitch. I would simultaneously stream to Twitch and YouTube, and I just never really found an audience on Twitch. So no one has been able to give me a good reason why I should switch over to Twitch as a platform, but I'm definitely open to it, and let me know if you can that. Is it possible one day to do a torus toroid coding challenge to explain the formula? Yeah, there will be no other live stream this week. This is it for this week. But I've got a lot of, well, not a lot. Right now I have 5 edited videos that have yet to be published. The 3 Frogger ones, which are there, you can find them. They're already unlisted. And then I guess 2 more from today. What was I going to say about, or something, okay, whoops, I got another minute and a half here. I hope people enjoyed this live. I felt like I was kind of a little off my game during the refactoring video because I was just sort of spaced out refactoring, but hopefully that was useful and it'll get edited into something useful. Can a gambling game be predicted with machine learning? Actually, there's been some recent research and work done in training an artificially intelligent bot to beat professional poker players. Absolutely. So, but you know, a pure chance game, there's no way you're going to win at blackjack. I mean, you can play optimal strategy, but you're not going to have an edge. But for a skill-based game, you absolutely, like poker, you absolutely could teach an AI agent. How long, someone is asking about editing the videos. Mathieu at mathblank on Twitter helps edit all the videos, and they usually are done within a few days, but I would say, you know, within a week is kind of always our goal. When will we see you program in C? It's a good question. Maybe someday, maybe never. Okay, 3:36, I've really got to get going. What I would really like to, so I do have this list here of continuing to follow up, but I think when I come back, I'm going to finish off the Perceptron stuff because I really want to get to building the neural network. It's just stuff, everything takes so much longer for me to make than I think it's going to do. Hopefully, when I get back later in June and the first couple weeks of July, I mean, there's a July 4th holiday, but I'm going to try to do, a couple weeks, I'm going to try to do 2 live streams each week because I'm going to also be away traveling for 2 weeks in July. I'm also going to be away for 2 weeks in August. So there'll be 2 weeks where I'm here in July and 2 weeks where I'm here in August and the other 2 weeks when I'm away. All right. Thank you, everybody. Thanks for watching. I will see you all next week sometime. But please stay in touch, write comments, like, subscribe, tell your friends about the channel. You can always tweet me at Schiffman is a good way to send me some feedback. I read all the mentions for sure. I mean, emails, I probably reply to half of them because I miss a lot. But you can always get in touch with me. And the comments, I read all the comments on YouTube as well and try to reply to them as I can. Okay? Thanks, everybody. And I will see you next time. Yeah, people are asking for more 3D challenges. I think that's a great idea. I'm not very good at 3D. I'm very 2D. Okay, I'm going to